Okay, this is example 8. Our function is f of x equals x minus 4, all divided by x squared minus x minus 6. In this case, the denominator is in standard form, so we need to factor it. And this will be helpful to determine if it's already simplified. So remember, anytime that you factor something, double check the factors just to make sure. So when we subtract 2x minus 3x, you get minus x, and everything else is correct. So let's check the domain. Set the denominator not equal to 0, and solve. So we wind up excluding positive 3 and negative 2 from the domain. Next, we're going to check the x-intercepts. So set the numerator equal to 0 and solve. Remember to write your intercepts as points. Next, check the holes. Since the function's already simplified, evaluate the function using the values of x you excluded in the domain. So f evaluated with negative 2. And you can see from that last part, we're going to divide by 0. So this is not a hole. And evaluate the simplified function with positive 3. And again, you can tell that we're going to divide by 0. So this is also not a hole. There are no holes in the graph for this particular function. And since we divided by 0, both of these values will be the vertical asymptotes. Remember, always write asymptotes as an equation of a line. Next, check the y-intercept. The y-intercept is when x is 0, so evaluate the function with a 0. And I decided to use the denominator in standard form since it was easy. So we have a y-intercept of 0 and 2/3. Always write the intercepts as points. Horizontal asymptote, compare the degrees. So the degree of the numerator is less than the degree of the denominator. Our horizontal asymptote y equals 0. This means there are no slant asymptotes. And it also means that the end behavior model is that equation y equals 0. All right, let's graph this, put everything together. So start off by plotting the intercepts and any holes that are present. So our y-intercept 2/3, x-intercept of 4. We've got a vertical asymptote at 3. Second vertical asymptote at negative 2. And our horizontal asymptote, you don't have to draw a dotted line, but label it just so that you remember what it is. Next, we're going to consider the graph to the left of our vertical asymptote x equals negative 2. So the graph can either appear above or below, not both. And in order to determine which, we're going to test an x value of negative 10. It's not going to cross the x-axis because there are no x-intercepts, so I know it has to be either above or below. So evaluate negative 10. We're just checking to see if it's positive or negative. And in this case, it's going to be negative, which means the graph is going to be below the x-axis. Put your arrows there. Now we're going to consider the graph between the two vertical asymptotes, and it can either come from the bottom and go up, which means it will have to cross the x-axis in order to connect to the y-intercept, but there are no x-intercepts here, so we know that it cannot do this, which means that it's going to have to come from the top down. and then go back up like that. Now, I don't know if 2/3 is a vertex, but we're not interested in that kind of accuracy. You can test some other values if you want to, but that's unnecessary as long as you connect the intercepts with the asymptotes. That's all that we're interested in here. Now let's look at the graph on the right side. In this case, we have an x-intercept, so we know it's going to cross the x-axis there. So it can either come up from the bottom or come from down from the top. So let's test another value, pick x equals 10, and see whether it's positive or negative, and that'll tell us how to draw the graph. So this turns out to be a positive value, which means the graph is going to start at the bottom and go up, and then come back down just a little bit towards the horizontal asymptote. And there is our final graph.